So here we have some graphs of functions, and we want to use the graph to determine the domain and range of each function. So the domain of a function is the x values or input values for the function. So the x values in a graph are the left-right values. So let's see where we have graph looking left to right. So for this function, we don't have any graph over here to the left of -2, and we don't have any graph over here to the right of 3. So all of the function values are here between -2 and 3, looking left to right. Looking at the endpoints, we see this left endpoint at -2 is included because this point here with x coordinate -2 is included. But the right endpoint at 3 is not included because we have this open circle here to show that the point with x coordinate -3 on our graph is not included. So we see that our domain for this function is the interval from -2 to 3, with the 2 being included, so we put a square bracket there, and the 3 is not included, so it gets a paren. Using inequality notation, this is all of the x values where -2 is less than or equal to x, and x is less than 3. So looking at the range is all of the output values or y values for the function. So the y values are the values looking up and down. We see that the graph hits a maximum value and turns around here at 4. So we're not going to have any values higher than 4 for our range. And the graph, we've got graph like kind of in here in the middle, and it stops and hits a lowest point down here at -5. So we don't have any graph below -5. So all of our function values are between -5 and 4 in the y direction. So that's going to give us our range. Asking about endpoints. The endpoint here at 4 is included because this point 0, 4 is a point on the graph with that y coordinate. So the y coordinate 4 is part of the range. However, if we look at this bottommost value, -5, it is not included because it has that open circle. So that y value, -5, is not included. And our range is the interval from -5 to 4. The -5 is not included and the 4 is included. In inequality notation, our range is all of the y values where -5 is less than y and y is less than or equal to 4. So that's our domain and range for this first example. Our second example is just a straight line. It does not have open or closed circles to indicate endpoints. So what that indicates is that this graph is actually continuing forever in both directions. Just imagine this line extending on and on forever on both ends. So that means looking at our possible x values, we don't see it on the graph but the line is continuing out on past this -2 and continuing out on past this 5. It's just going on and on forever in both directions. So that means that it will eventually reach every x coordinate, and it will eventually reach every y coordinate. So both the domain and range are the entire real number line, which in interval notation is the interval -infinity to infinity. Domain is our x values, so in inequality notation, this is -infinity is less than x is less than infinity, and the range is our y values. So in inequality notation, this will be -infinity is less than y is less than infinity. And for our final example, again, this graph is continuing forever, going down in both directions on the left and the right. That means that we will eventually get every number left and right. So our domain is again all real numbers. So here we have it in both interval notation and inequality notation. When we look at the y values to find our range, we do see that the graph is continuing downwards forever. So our range is going to get infinitely small. However, the graph turns around and does not go above this point here that has y coordinate 5. So our range actually stops at 5, and that 0.05 is included. So what we have here for our range is the interval going down forever, so from -infinity up to 5 and including the 5, and in inequality notation, that's the interval -infinity is less than y, which is less than or equal to 5. So there are some examples to show you how to read domain and range off the graph of a function, and I hope that that was helpful.